Welcome to today's class. Today we are going to discuss the strain, which is under the subject of structural mechanics in chapter 1. So we will learn about the basics of a strain. A strain is basically the ratio of change in length in a member to the original length. And this change in length, that is denoted by delta L, is measured in the direction of force. So if delta is the change in length and capital L is the original length of the member, then the ratio delta L by L is the value of a strain, which is a relative deformation, and it is denoted by epsilon. As you see here, this is the ratio of two length parameters, so it is dimensionless also. If we discuss what are the various types of a strain, so by going one by one, the most common strain is a linear strain, which occurs in the direction of the action of force, in the line of action of force, and this is equal to delta L by L, the change in length divided by initial length. The lateral strain, if we discuss, this is the strain developed in the direction perpendicular to the direction of the line of action of force, and if the dimension, lateral dimension of the member is d, then the change in d, delta d divided by the initial value of d, that can be a formula for calculation of lateral strain. Similarly, the third type of strain is volumetric strain, that is the change in volume divided by initial volume. And there could be a shear strain, that is the strain developed in a member in a surface because of shear stress divided by the initial length of the member, which has been deformed to some other position. If you go one by one, the linear strain is basically understood if a member is, suppose this member is under a tensile force P, and it is a tension force, so it is increasing the length by delta L. So this linear strain in this case becomes delta L by L, and this is the case of elongation. If a member is here, is applied by a compressive force and it shortens the length of the member by delta L, then here in this case the strain, linear strain is equal to delta L by L, that is compression. So linear strain can be either because of elongation as well as because of compression. If we discuss lateral strain, and if you take a member which is applied by a tensile force and its cross section, if you see on the top, is a rectangular one, it has two lateral dimensions, capital B and capital D. So if it is a tensile and it elongates the member, then its lateral dimensions B and D both are changed to, suppose, a small b and a small d. Then the lateral strain becomes the change in lateral dimension, that is b minus small b divided by b, capital B. Similarly, in other dimensions, capital D minus small d divided by initial value of capital D. So this way we can take the ratio and we can find the value of lateral strain. If it is a circular member, the initial diameter is capital D, and after deformation the diameter reduces to a small d. So the change in diameter is capital D minus a small d, and divided by the initial value of diameter, that is capital D. So this way we can get the value of lateral strain. If we discuss what is shear strain, so shear strain basically is caused because of shear force, which is shown as capital Q here, and it is acting parallel to this surface. Because of its action, this surface is moved in its direction by, suppose, C dash, and the ratio of C dash by the initial position of this surface length CD is the ratio of shear strain. So if it is a square element, then this is CC dash by BC, and this way we can get the value of shear strain. The next type of strain can be volumetric strain, that is a totally volume parameter, change in volume because of any application of force. So the ratio of change in volume delta V by initial volume capital V is the ratio of volumetric strain. How to calculate the delta V? So the initial volume is BdLi and the final volume is BdLf. So this difference gives the change in volume divided by initial volume, that is BdLi. I means initial volume parameter and F is for final volume parameter. So this way we can find out the volumetric strain. Now the next important term is Poisson's ratio. Basically Poisson's ratio is defined as a negative ratio of lateral strain divided by longitudinal strain And longitudinal strain is basically the linear strain. So a ratio of lateral strain by linear strain is known as Poisson's ratio. With this basic informations and definitions of various terms related with the strain, we can now solve some numerical problem. So if you take an elastic band, suppose a rubber band, and stretch it so that it is twice longer than initial, then the strain will be equal to 1. Now see, if it is elongated twice its length, so the increase in length is equal to its initial length. So the increase in length is the actual length divided by the initial length, so this becomes equal to 1. So the strain in this case is 100%. The formula for the strain is epsilon equal to delta L by L1, and this is change in length L2 minus L1. So L2 is 2L minus L1 is L only, so 2L minus L is L divided by L, so this becomes 1. So strain equal to 1 means it is 100% strain value. Another problem if you take here, suppose a cord has original length of 100 cm and is pulled by a force. The change in length of the cord is 2 mm. Determine the strain. Here we have given original length L0 100 cm, that is 1 meter. The change in length delta L is 2 mm, that is 0.002 meter divided by 100. 2 divided by 1000 is 0.002 meter. And so to calculate a strain, you can find out that a strain is equal to change in length, that is delta L divided by the original length L0, and this is equal to 0.002 meter divided by 1 meter, and this becomes 0.002, that is the value of a strain. So by knowing the basics of a strain, we can apply this in solving engineering problems and we can get the value of a strain. So with this, thank you very much for listening this lecture patiently about a strain.